First of all, let me start by reminding you that fractions are actually a division operation. When you see a fraction like 1/2 or 1 over 2, what it means is 1 divided by 2. So that's equivalent to 1 divided by 2. And that's an important piece of information here because it's going to come into play a lot in algebraic fractions, more so than it would with just integers or rational numbers. Secondly, let me remind you that, for example, 3 over 6, normally you would simplify that to 1 over 2, but there's a few intermediate steps that I'd like to go through just to remind you actually what's happening. So let me get rid of that. The 3 over 6 is equal to 3 over 2 multiplied by 3. That's the 6 is 2 multiplied by 3, and that is equal to 1/2 times 3 divided by 3. And you often call this cancelling, where you say that 3 over 3 is 1. But again, it's the division operation really. It's 3 divided by 3 is 1. Again, it's often called cancelling, but it's a division operation. And that's how you get to a half when you don't skip any of the steps. Let's say we're given this example then, 15y to the 5th power divided by 3y squared. Now first of all, just remember, because fractions are essentially a division operation, y does not equal 0. Very important, you can never ever divide by 0. So, I'm going to take this 15y to the 5th and I'm going to write it as 3 times 5 times y times y times y times y times y, and that's divided by 3 times y times y. So the 15 becomes the 3 times 5. Y to the 5th is 5 y's multiplied by each other, and 3y squared is a 3 times a y times a y. So this 3 divides by this 3, or cancels with this 3. You get 1. I can divide this y by this y to get 1, and I can divide this y by this y to get 1. So what we're left with is 5 multiplied by y cubed. So we have a 5 here and 3 y's multiplied by each other. Let's take a look at this example then. 18a cubed times b to the 7th divided by 6a times b to the 4th. And once again, in fact, you'll probably be told this at the start of the question, that a and b don't equal 0, because we're dividing by a and b and we can't divide by 0. If this comes up as part of an equation or an inequality in a question, it may turn out that a and b look like they're solutions, but actually they're not, because this is what you're starting out with. So I'm going to rewrite this as 3 times 6. You can write it as 3 times 2 times 3 if you like, but it's not going to help very much in this particular case. I'm going to keep my a cubed and b7 as they are. And on the bottom I've got a 6 times an a times a b to the power of 4. Now first of all, my 6's are going to cancel with each other, or divide by each other, so I get the 1. And if you haven't taken a look at our lessons on indices yet, let me just remind you that, let's say, x to the m divided by x to the n is equal to x to the m minus n. All of this is part of the power of x. So let's say in this case we have the 3. The a is now to the power of 3 minus 1. Remember, the a on its own here is just a to the power of 1. And b is taken to the power of 7 minus 4, because we have the 7 here and the 4 in the denominator. So that gets us 3 times a squared times b cubed. Now in this example we're going to need to use some factorization. So again, if you're not comfortable with factorization, then do take a look at our lessons on it. So I'm going to factorize this as x times x plus 4 because the x is common in the numerator, and in the denominator 3 is common. We have a 3 in the 3x, and 12 is 3 times 4. So we've got 3 times x plus 4. Now this is something that we can cancel or divide. But once again, let me just remind you that x does not equal minus 4, because if x is minus 4, then we have minus 4 plus 4, which is 0, and it will mean dividing by 0, which we can never ever ever do. But let's say x doesn't equal minus 4, then we can cancel these two, because they're just numbers. Whatever value x has, this is just going to turn out to be a number, and we can cancel variables as well, the way we did with this a's and b's up here. So yes, x over 3. And that's about as simple as this one is going to get. With this example, again, we're going to need to do a little bit of factorization. It may not be immediately obvious what to do, but note that the top here is two squares with a minus sign in between them. It's 2p all squared. Remember, this 4 isn't squared in this case. We have to make it a 2 so we can get the whole thing squared. And the 9 is 3 squared. That's divided by 2p minus 3. And you can't divide at this stage. These two are separated by the minus sign, and they've got the squares, so these two things are not equal. You can't cancel them yet. What we have to do is factorize this numerator. So it's a difference of two squares, which means we're going to get 2p minus 3 times 2p plus 3. And that's all divided by 2p minus 3. Now we can do a cancellation, because 2p minus 3 divided by 2p minus 3 is just going to be 1, as long as p does not equal 3 over 2. So the final answer for this is 2p plus 3. With this example, again, we can't just do any cancellation or division immediately. We have to use an intermediate step of factorization. This one is just a regular quadratic that you factorize, and it's going to turn into x minus 3 times x plus 2. And we're looking for two factors of minus 6 that add together to get minus 1, which is how many x's we have. And in this case, the minus 3 times a plus 2 is minus 6, and the minus 3 plus 2 is minus 1, which is how many x's we have. So all that is divided by x minus 3. And once again, provided that x does not equal 3, no amount of stress will ever be enough that x does not equal 3. But if the x doesn't equal 3, then we can do our division. The x minus 3 divided by the x minus 3 gets 1. So that leaves us with x plus 2. So, thanks for watching, and I'll talk to you in the next lesson.